How did geotechnical engineering stabilize the Leaning Tower of Pisa? Imagine standing beneath one of the most iconic structures in the world, marveling at its tilt and wondering how engineers managed to preserve it for centuries. The Leaning Tower of Pisa has fascinated visitors since the 1200s, but its famous lean posed a serious challenge for preservation. Over the years, various methods were considered to prevent further tilting and potential collapse. The solution involved innovative techniques in geotechnical engineering, which focuses on understanding and manipulating soil and rock behavior beneath structures. Initially, the primary concern was that the tower's foundation was built on soft, uneven soil that could not support its weight evenly. The ground beneath the tower consisted of clay, sand, and other loose sediments, which caused the structure to sink and lean. To address this, engineers first conducted detailed soil investigations to understand the composition and stability of the ground. This information was crucial for designing effective stabilization methods. One of the most significant interventions was the removal of soil from beneath the higher side of the foundation. This process, known as soil extraction or soil removal, involved carefully excavating soil from the area that contributed to the tilt. By removing soil from the higher side, engineers effectively reduced the tilt angle, allowing the tower to settle into a more stable position. This technique was carefully controlled to prevent sudden shifts or collapse. In addition to soil removal, engineers used a technique called soil stabilization. This involved injecting grout into the ground to fill voids and strengthen the soil structure. The grout, a mixture of cement and other materials, improved the load-bearing capacity of the soil and reduced its tendency to shift. This process helped to stabilize the foundation and prevent further tilting. Another innovative approach was the installation of counterweights and anchoring systems. Engineers added lead counterweights to the higher side of the tower to balance the lean. Anchors were embedded into the ground and connected to the tower to provide additional support and limit movement. These measures helped to maintain the tower's current position and prevent further deterioration. Throughout the stabilization process, continuous monitoring was essential. Engineers used precise instruments to track any movement of the tower and soil conditions. This data allowed for adjustments and ensured the safety of the structure over time. In summary, geotechnical engineering stabilized the Leaning Tower of Pisa through a combination of soil removal, soil stabilization with grout injections, and the strategic use of counterweights and anchors. These efforts successfully halted the tilt's progression and preserved this historic monument for future generations to admire.